Alright, so let's look at some examples. Determine which postulate or theorem proves the triangles are congruent. Then write the congruent statement for the triangles. First, we have to check if we have at least 3 things marked congruent. We have to have 3 things every single time. Even our hypotenuse leg theorem had 3 things, remember, because we implicitly knew that we had a right angle. Do we have at least 3 things marked congruent? And then we need to go ahead and mark the things we have with an A for angle or an S for side. And we also have to mark what we don't have with an X, and you will realize why we do that. Okay then, let's look at our first example here. We have angles K and M being congruent. We have segment TK being congruent to HM, that's a side, and we have segment KV being congruent to JM, that's also a side. But there is a bunch of things that we don't have. We don't have angle V, we don't have this side, and we don't have angle T. So those I'm going to mark with X's. And now in order to determine which postulate, remember not just that it's congruent, but which postulate or theorem proves it, we now have to go with our letters and see which one it actually is. We can start, for example, at this S, and now the thing is we can never go across more than one X. So here we have 3 X's next to each other, so we can't go in that direction. That means we have to go from S to A to S, and that gives us the answer, which postulate we are using. We are using the side angle side postulate, SAS, and we can now write our congruent statement. Triangle TKV is congruent to. Now again, let's make sure that we don't make a mistake here. We're going from the side with the 1 mark to the side with the 2 marks, and this is the order we went. So we now have to mark our second triangle HMJ. There is our postulate and our congruent statement. Let's look at our next example. What do we have? We have 2 sides that are congruent, and we have an angle that's congruent. The right angle is congruent to the right angle of the other triangle. We do not have the measurement of this angle, of this side, or of this angle. So let's start here. We cannot go from the S directly to the A because there are 2 X's. We have to go to the other S and then to the A. So that would be S, S, A. But wait a minute, we said we can't use SSA, right? That's true. However, we have a right angle here, and therefore we can use our HL congruence postulate, and now can therefore say triangle BCU is congruent to triangle. So we went from the right angle across the side with 2 marks to E and to the other side. So triangle BCU is congruent to triangle FEW. Let's look at this example. Here we only have 2 sides marked congruent. This side is congruent to this side. PQ is congruent to RN. But we don't have a third piece of information. But we are in luck, because if we see that RQ, the segment, actually is part of both triangles, we can use the reflexive theorem and mark this side congruent to itself. And there are our 3 pieces of information, our 3 sides. We don't have any angles, so none of the angles work, but we have 3 sides, and we can go starting from any of the sides, going to the next and to the next. And therefore we are using the side congruence postulate, and our triangle PQR. I'm going from P across the side with 1 mark to Q across the side with 3 marks to R. That triangle is congruent to the triangle NRQ. We can also use our congruence theorems when we have to state which is the third or missing congruence that we would need to prove that 2 triangles are congruent, and we have to use a given postulate or theorem. So in example 4, we are given that the side FE is congruent to the side ON, and angle F is congruent to angle O, and we're supposed to use the AAS, angle side congruence theorem. Now, first of all, we are going to mark everything we have congruent and see what else would we need. FE is congruent to ON, and angle F is congruent to angle O. So we're supposed to use the angle side theorem. In other words, we need 2 angles and a side, but the side is not included. The side is not included between the 2 angles, so we cannot use angle E and N. Well, that leaves us with angle D has to be congruent to angle M. Angle D needs to be congruent to angle M. And let's just make sure that we did this right. We have an angle, and a side. We don't have this angle, we don't have this side, and we don't have this side. We cannot move across 2 axes. We can move from A to A, and from there to S. So yes, we did use the AAS, angle side congruence theorem. In our next example, we have given side DF is congruent to side MO, angle F is congruent to angle O, and now we're supposed to use the angle side angle congruence postulate. And again, the first thing we do is we mark the things we have. Side DF is supposed to be congruent to side MO. Angle F is supposed to be congruent to angle O. And we're supposed to use the angle side angle congruence postulate That means we need a second angle, and the side this time is actually the included side. So if we have angle F, the other angle that includes side DF is angle D. So angle D needs to be congruent to angle M. Angle D needs to be congruent to angle M for us to be using the angle side angle congruence theorem. Let's see what we have. We have an angle, we have a side and another angle. Don't have this side, don't have this angle, don't have this side. We can go across the three axes, so no matter which A we start from, we go from A to S to A, and we have indeed used our ASA. Okay, that's it for today. For your summary, I want you to write the 5 shortcuts, the 5 theorems or postulates of congruence that we can use to prove triangles are congruent. And I want you to specifically compare and contrast AAS and ASA. Alright, that's it for today, and I will see you in class.